Let's look at the Truffle Pet Shop example working on the NEAR EVM. At the time of this video, it's on betanet. So there is like mainnet, testnet, and betanet kind of before that. And it will be on testnet and mainnet fairly soon. So what is this pet shop? If you haven't heard about it, it's this beloved example from Truffle, kind of an older example, popular with hackathoners who need to get started with their first Ethereum Solidity app. So it goes through and basically explains everything about how you get started. Here we're installing Truffle globally. Truffle is a development framework. And then we kind of keep going down here. It goes over basic smart contract. We will peek at it here. This is live on betanet. I will have this URL in the description of this video. So let's just glance at this really fast. So we have a bunch of dogs here, 16 to be exact. And some of them have like success. They've been successfully adopted, thank goodness. Others have adopt. Note that these buttons are disabled, but we can still see which dogs, can be adopted, and to actually adopt them, we would follow the directions and log in here. Before we do any of that though, let's check out the basic Solidity code. Under contracts adoption. This is extremely simple. We got our pragma up here, and then this is the entire contract. So we've got 16 Ethereum addresses. This is a primitive in Solidity. And there's a function to adopt a pet, and you give it the number. So if you wanted to adopt pet 0, that would be Frida, 1 is Gina, and so on. You can get the adopters. And I actually added this final function to clear. Now I want to jump here. So once you compile a smart contract, there will be this build artifact, and it will be in this sort of directory structure, build contracts, and then the name of the contract.json. So if we jump to the bottom here, this is the EVM address where this contract lives. And this number right here corresponds to the chain ID. So the betanet and testnet and mainnet are actual EVM networks, as we can see right here. So betanet, this is where that number is coming from. Great. And then we go to the top. And this is a really important part. This is the application binary interface. And this is going to tell us information about the functions, what they accept, and what they're returning. So for instance, let's just look right here at the adopt method. It's going to be taking a uint256, and then the output is going to be returning a uint256, and so on. So this goes through, get adopters, doesn't have any input, doesn't take any arguments, and so on. I'm going to just start from scratch. I want everyone to see the entire process. So let's just delete that, and we'll build in a second. I think it's important to first look at the truffle config.js. In the project, it's in the root here. So if you've used Truffle before, this looks very familiar. I think typically someone would see something like this at the bottom. And usually you would have like a ganache spun up for Ethereum, and you can point to that. So what's really neat about Truffle here is that we are able to use our own custom provider, NEAR Provider. So this is a library published to NPM. And so if I'm going to go to betanet, here we have the ability to just specify which provider we're going to be using. So we can instantiate our provider, tell it which network it is, and this is saying, let's take an environment variable of the betanet NEAR account that we're going to be using here. Cool. So we're going to run truffle migrate, which is essentially compiling the contract and then also deploying it. And I will be providing the NEAR master account that we saw in a second ago. So the NEAR master account is going to be mike.betanet. You can feel free to go to the betanet wallet linked in the description and create your own. Truffle migrate, and then we simply just select which network it's going to be. NEAR_betanet, NEAR_betanet. Compiling the contracts. Okay, starting migrations. which is kind of synonymous with deploying. Okay, migration. We're not going to really be concerned about that. Let's really focus on the adoption contract here. Okay, cool. So if we scroll up, we will see this block is kind of important. And here we are, the contract address. So it successfully deployed the pet shop contract to this address in the NEAR EVM on betanet. Great. So we'll see up here that the build folder is here. After we've deployed this, we can run the website saying, let's take a look at betanet. Okay, and now we see that all of these dogs have the adopt on them since none of them have been adopted. Great, but we're still disabled on all the buttons. Okay, so let's go ahead and just log in here. This is going to betanet. Brotoshi, I forgot I made that. Let's allow. This is the normal workflow when dealing with the NEAR wallet, actually. More on that in the documentation. So now we're logged in as Brotoshi. And here we are. I have been historically biased toward Melissa. So I'm going to click adopt. Now it is using the NEAR provider to speak directly to the EVM, essentially, taking my NEAR account brotoshi.betanet and turning it into like a derived EVM address and sending a transaction from there. Great. At the top, we see Melissa's adoption in NEAR Explorer. Now, at the time, this is not going to be all that pretty, but this is similar to like Etherescan, and we can see that we sent from this account to the EVM and the gas used. And so now we see a success here. That's like a very simple explanation of this. There's a couple of things that I want to note also, that when we were logged out, we could still see which dogs were adopted. So let's go back to this other one. And what's happening here is this is a different instance of the same contract deployed to another address. So this one just still lives, right? This one has Collins and Melissa that are adopted. So what this means is we haven't logged in here, but our NEAR provider is able to just read from the EVM. So there's kind of two modes here for the NEAR provider, read only and interact and do mutable methods. So what is this whole thing right here? Like, where is this web page coming from? If we look inside of source and then index.html, nothing super interesting. I actually really appreciate how the Truffle pet shop doesn't take any stance on JavaScript frameworks. It's just, I think jQuery is the only thing used here. The most important note here is line 74 having app.js. So that's really where everything else lives. The rest of this HTML file is for setting up the buttons and whatnot. So everything is contained in app.js. I think I'll just go to the top here. Just a couple of small things. Look at these imports here. So again, we're using NEAR Web3 Provider. And below that, we have Web3 ETH contract. Now, this will look really familiar to folks who are already doing Ethereum development. We can still use the abstraction of this library and simply swap in the NEAR provider, which we'll show in a second, and then Web3, of course. Okay, so there's some basic initialization going on. This is mostly going to be populating the DOM here with pictures of dogs. And at the bottom, we say, okay, cool, that's done. Now initialize Web3. So here is where we are talking about the read-only mode versus the mutable mode. So if we're logged in, then we're going to say, all right, we have a master account ID. Please use this when sending transactions to the EVM. And if we're not logged in, then we're going to say, yes, this is a read-only. There are a few different types of key stores in NEAR. In this particular case, we have like a website, and so we're going to be storing keys in local storage. application, local storage down here. So brotoshi.betanet, and this is a private key, but feel free to steal that if you want. This is what's called a limited access key or function call access key. If you steal this, you can't move any tokens around whatsoever. This is a very powerful part of NEAR that, quite frankly, I don't think we've fully flexed yet, but definitely learn all about the NEAR account system in the docs. So that is why we have this line where we're specifying we're going to be using browser local storage for this. You can also have in-memory key store, as well as unencrypted file system key store. So say you're using a CLI or something, you don't have access to like window dot, and you can load a private key that's just in a JSON file somewhere safe. Okay, so back to the flow here. Let's just keep going to the next part. Initialize contract. So here we are going back to that JSON file I showed you, the artifact build contracts adoption.json. We can get all kinds of information, the chain ID and whatnot. And here we are using Web3 ETH contract, instantiating it. And then, as I mentioned earlier, we just set the provider to use NEAR Provider. So boom, it works. Those things play very nicely, which is awesome. Really, there's only two things that's happening here, right? You want to see what dogs are adopted, and you want to adopt dogs. So super simple. This will look very familiar to everyone who's done Ethereum and Solidity development and that talks to a front end. Nothing different really. We're saying there's contracts. It's going to be called adoption. Has a method, get adopters, and then we just call from here. And we loop through, and essentially when we were talking about the addresses stored in Solidity, if there is a 0 address, that means this poor doggy is not adopted, and if it has a non-zero address, then it means that it is adopted by someone. So actually here you can also see that when we are clearing it, we are setting the adopters to address 0. So that's how this determines which dogs are adopted and not. Login is very similar to all the examples. I won't really go over this. If you want to see more examples like this, near.dev is a website that'll refer you to lots of examples that kind of break down the request sign in and using the NEAR wallet flow. So then here is the handle adopt, and this is, I think, the last part that we need to show. We are going to adopt which pet ID, whichever one they clicked on, from the account, in this case, brotoshi.betanet. And then we get back the transaction hash, which allowed us to open up NEAR Explorer and see what happened. Now, I do want to mention that this particular case that I'm talking about is using a provider, and you have a NEAR account that you're going to be speaking to the EVM with, or else you can use this sort of wallet flow that we have here where we can log in using NEAR wallet and then have a NEAR account where you can talk to the EVM. This is an interesting approach, and I think this is great. Currently, the team is working on making a proxy Ethereum RPC server. That's actually a lot of the way there. I won't show it in this video because this video is mainly demonstrating the NEAR Web3 provider, but that will be essentially, in terms of the Truffle config, it would look more like this. So yeah, thanks a lot, folks, and look forward to seeing what folks build on the NEAR EVM.